Okay, we're back after that slight interruption. Take a look here. Now what I want to talk about, and before I go on, the group and I were able to have a really good conversation about the fact that if you change the amplitude or you change the period, which in turn will change the critical interval, you're not changing the shape of the graph. Let me do something that we did off camera that I thought was kind of neat. We went up to 1, we went down to -1, we did the sine curve, and we said that this would be 90, this would be 180, this would be 270, that's 360. We did this, we did this. Luke, am I still on the screen? Yeah. See, Luke's here, and we've got that happening. All the cool kids are here. And what are we going to do? So this is y equals sine theta. Frank, give me your favorite number between 0 and 10. 5. We're going to change this. Look. 5. -5. I have just taken this curve and made it. All I have to do is change the scale. And that changes the actual curve that's being sketched. Now, what if I change this to 45? Change this to 90. Change this to 135. And change this to 180. I just did a horizontal compression, didn't I? I've now sketched this. So again, the shape doesn't change. Vertical compressions, horizontal compressions only affect your scale. Ha-ha! But what about vertical and horizontal shifts? They're going to move that thing up and down, left and right. Okay? So vertical and horizontal shifts. You remember that f of x plus 1 means vertically shift or translated up 1 unit. You remember that. Move it down 2 units. Move it to the right 1. Move it to the left 2. We good? That's all things that made sense before. Well, now we're going to apply it to sine and cosine. So this one is sine theta plus 2. Now the first thing you got to be able to say is what's inside the function and what's outside. And this is implying that it's sine theta plus 2. So that's outside the function. It's outside sine theta. Look at this one though. The theta and the -30 is inside the sine, isn't it? It's what we call the argument of the sine. So that's going to be a horizontal shift to the right 30 degrees. Now, we have a special name for that. We call it phase shift. Why? Because we like to sound really smart and dignified. But it's simply a horizontal shift. But when we want to make people think that we're hoity-toity, we're going to call it a phase shift or a phase angle. So this one here, oh, look, I'm trying to be sneaky. I'm not telling you it's 30 degrees. I'm telling you it's pi by 6. In this context, pi is not 3.14. In this context, pi is 180 degrees. 180 degrees divided by 6 is 30 degrees. So this and this actually say the same thing, but in the opposite direction. One's going to the right, one's going to the left. Okay? Note, for trig functions, by the way, I won't be testing you on the pi notation, on what have you, but it is something that comes up a lot next year, so it's a good idea for me to start talking to you about it now so it doesn't seem so scary. So, note, for trig functions, a horizontal translation or shift is called a phase shift or a phase angle. And if necessary, we still have to common factor. See here, I have a horizontal compression and a phase angle or a phase shift. If I have both, I have to make sure that it's factored. So it's sine 2 theta minus 90. So it's not really movement to the right 180 degrees, it's movement to the right 90 degrees. And this one over here would be the same, sine the 2 theta minus pi by 2, which means that it is a horizontal compression and movement to the right pi by 2, which is 180 divided by 2, which once again is 90. Very good. Perform combinations and transformations in the following order. Stretches and compressions. This is done by setting up the vertical and horizontal axis. You won't see it. It's in your scale. Then you're going to do reflections. You'll see that. And then you'll see translations or shifts. Okay? That's our order. I'm going to pause the video here and then we're going to do the next example.